So now that we've seen the distributive property and how that works to eliminate parentheses, we have all the information that we need to be able to do subtraction with polynomials, right? Because as you'll see, subtraction of polynomials is practically identical to the combining like terms process we did to add polynomials. There's just going to be one extra step to get rid of some parentheses. All right, so take a look at this example. I want to simplify this, right? I want to get rid of those parentheses and then combine all the terms that I can. Okay, and to do that, I want you to remember that there's one of those implicit ones, right? You can think of there as being a 1 out here in front of these parentheses. It's 1 times 4a to the fourth plus 2a squared plus 3. Specifically, it's a negative 1 that's out here, right? That's the subtraction part. So to simplify this, I'm going to start with using the distributive property to distribute this negative 1 into the parentheses. If I do that, the front part stays the same, 7a to the fourth plus 3a cubed plus 6. Then this next part becomes minus 4a to the fourth minus 2a squared minus 3. Now all I have to do is combine any like terms, and I'll be done. So I've got 2a to the fourth terms, this one and this one. 7 minus 4, that's 3a to the fourth. There's only one a cubed term, so I'll just bring that down. There's also only one a squared term. And there are two constants. 6 minus 3 is plus 3. And that's my simplified version of that original expression. Right? You notice how I added the little arrows here. You know, I like to do that. Anytime I'm doing something where I have to make sure I check off every term, I'll put a little arrow under it. I'll cross it off. I'll do something so that I know that I have done everything I need to do with that term, and it doesn't accidentally get left out. Okay, so how about this one, right? This is just another example. It's got a little more going on because we've got some additional negative signs, right? So first, these parentheses out here in front of this first polynomial, they don't really mean anything. If there were a number out here in front, then okay, I'd have to use the distributive property first to get rid of them. But absent a number out there, this part is just 7x to the fourth plus 3x squared minus 4x minus 1. Now again, I'm going to think about that implicit 1 here. So I'm going to distribute minus 1 into the parentheses. Remember, all that's going to do is it's going to change the sign of everything on the inside. So plus 5x to the fourth becomes minus 5x to the fourth. Minus 4x becomes plus 4x. And minus 3 becomes plus 3. Now I can do the like terms and I'll be finished. I've got a 7x to the fourth and a minus 5x to the fourth. So that's 2x to the fourth. There's only one x squared term. There's two x's. Now look, minus 4x plus 4x. Minus 4 plus 4, that's 0. Right? So then I'm actually going to go ahead and write it in. So this is plus 0x. The minus 1 plus 3 is plus 2. Okay, we're not quite done this time, right? I would never put plus 0 anything, right? 0x is just 0, so I don't have to write it. So my final answer would be just 2x to the fourth plus 3x squared plus 2.